Now we're going to look at factoring two-term polynomials, and we're going to focus on the cubes. So this is the other formula I was talking about in the other videos. Really, when you're looking at two terms, I always factor using the special factoring formulas. With the squares, there was only one. A squared minus b squared is a plus b times a minus b. They're two binomial conjugates, so what's being squared in front goes in front, what's being squared in back goes in back. And then the sum of two squares, they're just prime, right? They don't factor. But on these, there's really only one formula here. Even though you look at this, it looks like a crazy formula. I'll show you it's not so bad to remember, and really they're the same formula, it's just some sign switching. And so I'll show you what I mean by that and how you can remember these. So if you're looking at this, the sum of two cubes, all sum of two cubes, I recognize as two-term polynomial, and I glance at the power and I see that it's a 3 or a multiple of 3. Same thing with the squares, they could be multiples of squares, and I can show you how to do some of those too. But what the deal is, when you look at this and I glance and I see that it's a 3, these multiply to a binomial times a trinomial. Higher powers, they multiply out to be a bigger thing. A lot of stuff wipes out on these. So here's the deal. When you look at this, they're essentially the same thing. I'm looking at the sum of two cubes, or difference two cubes. Notice the formulas are identical except for this sign and this sign. How I remember this. This is how I remember the formulas. If I'm looking at this, I go, okay, I know it's a binomial times a trinomial. I'll write that out right away. And then I go, okay, what's being cubed in front goes in the front of my binomial. What's being cubed in the back goes in the back of my binomial. Okay, so first, before I even do that, I actually fill the signs in all the way through it. There's 3 signs to fill in because it's a binomial times a trinomial. So what I'm going to do is, I remember this little acronym, SOAP. The sign is always same, opposite, always plus in the back. And if you can remember that, it's the same, opposite, always plus. So, I mean, that's just the way of remembering it. But really, it's always the same sign as what it was here. It goes in the binomial. The opposite always goes here, and then it's always plus no matter what, if it's plus or a minus. Both are factorable, the plus and minus cases in the two-term cube problems versus like in the square problems, only the difference was factorable. These are both factorable in the cubes. So same thing, like you'll notice, same, opposite, always plus. Now, I know it's binomial times binomial, so when I write this, I would fill in put my parentheses, I notice it's plus, I put my plus, minus plus, and then what's being cubed in the front goes in the front of this, what's being cubed in the back goes in the back. Now, how do you fill in the rest of these? You just take this, throw it in the front and square it, because you need that to be a cube when you multiply those back. You take this, throw it in the very back, and square it. What goes in the middle, just ignore your signs because you already filled them in. Just multiply these together and stick them in the middle. And that's it. So this is the deal in this one. It's going to be same, opposite, always plus, fill my signs in. What's being cubed here goes here. What's being cubed here goes here. Take this, throw it in the front and square it. Take this, throw it in the back and square it. Multiply them together, stick them in the middle. All right, and so let's practice this. So I threw up 3 examples here. They can get crazier. You can throw variables like we did in the other one for the back term and stuff, but it just does the same. But I thought these 3 kind of hit on it pretty well. So if I look at this and I go, okay, x cubed plus 125, I go, okay, well, I recognize there's no GCF, and I recognize there's 2 terms, that's telling me cubes. And I'm thinking, oh man, okay, it's the bigger problem. And this is really, and if you want, you can write this, you don't have to, but it's really x cubed plus 5 cubed. So just like with the squares, it's going to be helpful to get to know the different perfect cube numbers, like, you know, you might want to go 1 cubed is 1, 2 cubed is 8, 3 cubed 27, 4 cubed 64, 5 cubed 125, and so forth. So you can, don't really have to go too much higher with the cubes, and they start to get really big, so you generally won't see those in books. But anyways, I recognize that as a perfect cube. You have your technology with you to help you out on that too, so you can use that. I go, okay, cool, sum of 2 cubes. I don't care if it's sum or difference, they all factor. I know it's a binomial times a trinomial. Same, opposite, always plus. I fill my signs in right away and I got it. What's being cubed in the front goes in the front of this. What's being cubed in the back goes in the back. Once you can do that, you've got the thing, because you just basically take this, throw it in the very front of your trinomial and square it, because you need that x cubed. Take this, stick it in the very back, but square it. What's 5 squared? I'll just, since it's a number, I'll multiply it out to be 25, or square it out to be 25. Multiply them together to stick them in the middle. I'll stick the number in front, so it's a leading coefficient, but it doesn't matter if it's x times 5 is 5 times x, but it's just better to write it that way. You can ignore the signs on that then. Now, how do you know this is right? Well, you can go ahead and check your answer. Multiply your x all the way through. Multiply your 5 all the way through. You're going to notice a whole bunch of stuff wiping out, and you'll end up getting x cubed plus 125. Always works. That is how you factor cube problems. And it doesn't matter if it's a difference or a sum, they're all the same. You practice them enough, they're not that bad. So it's just, you know, remembering the formula. Don't try to, it's kind of a quicker formula to remember after you do a handful of them and you do it this way. I think it really works. So let's look at this. I just kind of try to pick a little bit trickier one. I see a GCF in this though right away. I know that 3 goes into 192 because 1 plus 9 is 10 plus 2 is 12. 3 goes into 12, so 3 is going to go into 192. So I'm actually going to take out that 3, and I'm going to be left with x squared minus 64. 64 is actually a unique number. It's a perfect square number and a perfect cube number. So it actually is a perfect cube because it's 4 times 4 times 4, or 4 cubed. Oops, I'm sorry, I made a mistake there. I wrote a square. It should have been cubed, right? We're dealing with cube problems. That was a cube. I recognize I have difference 2 cubes. That's really 4 cubed. So I can jump to my answer. Binomial times trinomial. I'm going to fill my signs in. I'll do a different color maybe so you can see it a little better. Same, opposite, always plus. All right. And then what's being cubed in the front goes in the front. What's being cubed in the back, which is a 4, goes in the back. Take that, stick it in the front and square it. Take this, stick it in the back and square it. Multiply these two together, ignoring signs, stick them in the middle. That's your answer. I also think, I see people trip up on this because of the 1 sometimes. So I'd like you to practice this. This 8 is actually a perfect cube number. There's no GCF. So I look at this and I go, oh, okay, wait a minute. I see that this is really 2 cubed, x cubed, so 2x quantity cubed plus 1 cubed is 1. So 1 is a perfect square number and a perfect cube number. It can be any power actually is 1. So I'm going to take out, I'm going to jump to the answer because I recognize they're both sum of 2 cubes. And I'm just going to fill in my signs. Same, opposite, always plus. What's being cubed in the front is a 2 and an x. What's being cubed in the back is a 1. All right, take this, square it, stick it in the front. You square the 2 as well, right? 'Cause that's part of it, so it's going to be 4x squared. Take this, square it, stick it in the back. Well, 1 squared is just 1. Multiply them together, stick it in the middle. And if you check your answer by multiplying that through, you'll see you get the right answer. That is dealing with factoring with 2-term polynomials when they're cubes. Or multiple of cubes, you can treat them the same way, and they may be multiple steps. But in this class, what we look at the ones where they're going to have a 3 for the powers. We generally don't look at the higher power ones until like in a higher class.